So now we're going to talk about the scientific method used in security and, well, the scientific method in general. So we will talk about the two major schools of the scientific method, deduction and induction, and then we will talk a bit about quantitative and qualitative methods and their differences and how they complement each other, and which one is good to use when. So we have two major schools of gaining new knowledge, deduction and induction. Both are used, but they have different strengths and weaknesses. So deduction, this stems from logic and mathematics. It's strongly associated with those. So the core principle is that we state some axioms which are ultimate truths that we simply assume are true. And usually these axioms are, most people believe that they are obviously true, and usually they are. We will see some examples. And then we use these axioms and formal rules, that is logic, to infer new knowledge. So in security, this is usually done with a system model and an adversary model. So we have the system model, which captures the core properties of the systems, of the system we're interested in. So we define how the system works and its properties. And then the adversary model captures the capabilities of the adversary. So that is what the adversary can do and cannot do in this system model. So we capture the properties in the system model, properties of the system, and the capabilities, so that is what the adversary can do in this system. And then we use these models as axioms and try to show security deductively. So obviously we need to define the security properties as well. So for instance, we have this very simple model. So there is a channel through which to communicate with Alice, and Alice do not know who is on the other end. So imagine a pipe through which you can talk, and on the other end of the pipe, which might go through a wall or something, there is Alice, and obviously she can hear you, but she cannot see who it is. So that's the system that we have, and the adversary that we imagine for this scenario cannot eavesdrop on the channel. So that means that when you are talking to Alice through this pipe, the adversary cannot hear what you're saying. The adversary is also computationally limited. So in the usual sense in computer science, this means that it's a polynomial time Turing machine. So it can do stuff, and it can do it fast, but not infinitely fast, so to speak. And then we have the security properties that we want from we want to construct a protocol which has the following security property. So Alice believes she's talking to Bob if and only if she is in fact talking to Bob. So if Bob goes to this pipe, our protocol will convince Alice that she's actually talking to Bob. And Alice is not convinced that she's talking to Bob unless she's actually talking to Bob. So if you or I go to the pipe and say, "Hey, I'm Bob," then Alice will not be convinced if she follows our protocol. So that's the idea. And if we have this example protocol, so one protocol that will try to achieve this this property in this system that we have defined, is basically password-based authentication, which you should be used to from anywhere on the web. It's kind of impossible to not come across password-based authentication. So basically, the protocol works as follows. It follows the usual way password-based authentication works. So Bob says through this channel, so through the pipe, "Hey, it's me, Bob." And then Alice replies, "Prove it." And then Bob says, "My password is password with a 4 instead of an A and a 0 instead of the O." And if this is Bob's password, if this is the password Alice knows to be Bob's password, then she's convinced that that she's actually talking to Bob, because no one else would know Bob's password. That's a fundamental assumption that we make here too, so we should actually add that to our axioms. So the question is, so we have a question that I want you to reflect on here, and that is this protocol secure in our model? And question 2, is this protocol secure in reality? That is it a good model? So think about that. We note that cryptography is the area which most stringently uses the deductive method. So of all the areas in security, cryptography is the most deductive one. It's most close to pure maths. And in many areas of security, it's not possible to use the full strict formalism required by maths. So to do deduction, to do deduction, one needs very simple building blocks with very few properties, because otherwise it will basically explode. You will have too much things to work with. So in many papers, it's more informal rather than formal arguments in the deduction, and occasionally we thus find vulnerabilities. But on the other hand, cryptography isn't perfect either. Although it has perfect deduction, it's not problem-free, because the axioms that you use must actually match the real world, and this is actually hard. So sometimes things are oversimplified, as was the case of our example, where we had assume that we have this pipe, and when you communicate, the adversary cannot see this. Well, if the communication is taking place over the internet, this is most definitely not true, because the adversary, anyone along the line, can actually see that there is communication. Sure, you can encrypt stuff, and thus prevent people from seeing exactly what you're saying, but that might be difficult in certain situations. So the other school, now that we've talked about deduction, so the other school was induction, which is basically hypothesis testing. So this is more commonly associated with the natural sciences, where you perform experiments and bring out new knowledge from that. So basically how induction works is that you form a hypothesis, which is your what you want to test. So your idea that, okay, this thing might work like this. And then you perform an experiment and collect data. And once you've collected the data, you analyze the data, and then you interpret this data and you draw a conclusion if this worked or not. And depending on your conclusions, you might have to return to step 1 and form a new hypothesis. So if the data doesn't support your hypothesis, you must form another hypothesis, because obviously the hypothesis you had was not true. But usually this the data will allow you to see some patterns, to form a new hypothesis, which hopefully is true, and then you can test that one and verify it. So there are some requirements on the induction process. So for instance, the experiments that one performs must test a hypothesis which is both testable and falsifiable. So the experiment must also have exactly one variable, and it must be reproducible, and the results must be repeatable. So what is testable and falsifiable? So we'll show this by an example. So this implies testable and falsifiable. It basically implies observability and measurability. So for instance, if we have the hypothesis that prayer increases contact with one's deity, this is not a falsifiable hypothesis because we simply cannot observe divine communication. So no experiment could prove the result wrong. Another example is the hypothesis this software is secure, and this is simply not measurable because we haven't defined what secure is. So we have to actually, if we know exactly what secure means, then we can actually measure it. So then it would actually be testable and falsifiable. Because if it isn't secure, then we can find an attack, and then it's not secure anymore. So the last part we're going to talk about is quantitative and qualitative methods. So quantitative methods, these explores things that are that can be objectively quantified. So for instance, measuring time, length, weight, cardinality, and things like that. Or depending on the definition of security, we might be able to measure security quantitatively too. And on this, so this is basically on one end of the spectrum, and then on the other end of the spectrum we have qualitative methods. So this explores things that are qualitative, that is subjective, and cannot be quantified. So this is usually used to explore phenomena in depth, and is especially useful for finding direction in usability research. So whereas now the natural sciences mostly relies on quantitative methods, then social sciences are more associated with qualitative methods, although they do use both qualitative and quantitative. But usually the natural sciences don't use the qualitative methods, they use quantitative methods. But the qualitative methods are very useful for in many situations anyway. We will see some examples now. So consider the following example. We've designed two interfaces and want to compare how good they are. Quantitatively, we can measure this by measuring the time it takes for people to finish a task in each of these interfaces, and obviously the interface that where they perform the task faster is how we define the term better in this case. So then we simply have a few users and we let them use this interface. We assign them the task, we let them perform this task, we measure how long it takes, and then we compute the average for everyone, and then we have an objective measure of how long it takes to finish this task on average. And hopefully our selection of the users is representative of the general population who is going to use this interface. A qualitative way of evaluating this interface would be to interview people about what they think of each of the interfaces. So for instance, we show these users the interfaces and we discuss the interfaces with them. So we let them use them, and then they can tell us what they think and what their thoughts are on the interface. So we basically discuss the interface with each one of them. So the quantitative results allow us to determine which of the two interfaces is the best, since we had everything quantitatively defined. The qualitative results, however, they allow us to extract what is good about the interfaces. So for instance, each of the interfaces might have good qualities, but neither of them is perfect. So with the quantitative measure, we can see which one weighs over to be slightly better, whereas the qualitative results actually might allow us to extract the best things out of both interfaces and construct a third interface which might actually be much better. So the qualitative methods can be very efficient for setting you in the right direction. And then, of course, you can verify that this third interface beats the other two by using a quantitative evaluation, same as the example that we had for the quantitative evaluation. But then you have to evaluate all three and see which one actually performs best. And that was everything that we wanted to talk about today.